I think we can start, Ayappa.
Ma'am, can we start? Hello.
Yes, there's a message start.
Okay, fine. Hello and good evening, everyone. Welcome to another project presentation from 360DigiTMG. Myself, Ayappa Bharadwaj. Today, I am going to explain about our project, price prediction of a new product in EdTech domain. This project is based on the regression model. Based on competitive pricing on similar product, we are estimating the price for new product in EdTech domain. We have completed this project under the guidance of Mr. Sharath Manikonda, Director of InnoDatatics, and Mr. Bharat Kumar, the mentor of this project. We heartfully extend our gratitude for continuous guidance. These are our team members. Myself, Ayappa Bharadwaj, Diksha Nandeshwar, Harshit Reddy, Rakesh Kavali, and Vinadar Kolli, who worked on this project. Now I am coming to the content of our project. These are our contents: project overview and scope, project goals and constraints, crisp MLQ methodology, technical stacks and project architecture, data preprocessing EDA, model description, model building and accuracy comparison, data visualization, model building, challenges and feature scope. The project overview and scope. Price is the prominent factor where people rely on the price, where it should be very low, where they need to take the new product. Also, it drives the student. It also plays a major role in churn reduction of student. Also, quality of the content should be good with less price. Price optimization also reduces the manual work and the errors of the human. Competitor price behavior analysis is done, which can assist the institutes for making better pricing decisions. These are the project goals. The goal of this project is to find best price of the course so that the student admission rate will be high with consideration of the profit margin. From this prediction, profit and quality of the content should be kept high. Now coming to the constraints. Since we are predicting a new product, price we have collected the competitors' data, there is a lack of data required for prediction. So we started web scraping for the process of estimation of competitors product and this web scraping. Stage is time consuming. CRISP MLQ. CRISP MLQ stands for Cross Industry Standard Process for the development of machine learning application with quality assurance methodology. It is a systematic process model for machine learning software development that creates an awareness of the possible risk and emphasizes quality. Assurance to diminish this risk is high. It consists of 6 steps to conceive a data mining project. They have the cycle, iterations according to developer needs. These are the steps of the business. And business understanding, data preparation, model building, testing and evaluation, deployment, and lastly, the monitoring and maintenance. The first step, business understanding. Developing machine learning application starts with identifying the scope of the ML applications and the success criteria. And the data quality verification is the second thing. The goal of this first phase is to ensure the feasibility of the project. We gather success criteria along with business and machine learning. On the economic success criteria during this phase, these criteria are required to be measurable. Confirming the feasibility before setting up the ML project is a best practice in the industrial setting. Applying in the machine learning canvas framework would be a structured way to perform this task. The ML canvas guides us through the prediction and learning phases of the ML application. In addition, it enables all the stakeholders to specify data availability, regulatory constraints, and the application requirements such as robustness, scalability, explainability, and resource demand. As data guides the process, data collection and data quality verification are essential to achieving business goals. Therefore, one crucial requirement is the documentation of the statistical property of the data and the data generating process. Similarly, data requirements should be stated and documented as well, as it becomes the foundation for data quality assurance during the operational phase of the ML project. The second step, data understanding. The second phase of the CRISP MLQ process model aims to prepare data for the following modeling phase. Data selection, data cleaning, feature engineering, and data standardization tasks are performed during this phase. We identify valuable and necessary features for future model training by using either filter methods, wrapper methods, or embedded methods for data selection. Furthermore, we select by discarding samples that do not satisfy data quality requirements. At this point, we also might tackle the problem of unbalanced classes by applying over sampling or undersampling strategies. That's third step, data preprocessing. The data cleaning task implies that we performed error detection and error correction steps for the availability of the data. Adding unit testing for the data will mitigate the risk of error propagation to the next phase. Depending on the machine learning task, we might need to perform feature engineering and feature augmentation activities. For example, such methods include one-hot encoding, clustering, or discretization of continuous attributes. The data standardization task denotes the process of unifying the ML tools. Input data to avoid the risk of the erroneous data. Finally, the normalization task will mitigate the risk of bias to feature on large scales. We build data and input data transformation pipelines for the data preprocessing and feature creation to ensure the ML applications. Reportability during this phase. The next phase, model building. The model building phase is the ML specific part of the process. The phase aims to specify one or several machine learning models to be deployed in the production. The translation to the ML task depends on the business problems that we are trying to solve. Constraints and requirements from the business and data understanding phase will shape this phase. Generally, the modeling phase includes model selection, model specialization, and model training task. Additionally, depending on the application, we might use a pre-trained model, compress the model, or apply ensemble learning methods to get the final ML model. Finally, we package the ML workload in a pipeline to create repeatable model during the model phase. And then next phase, evaluation. Model training is followed by a model evaluation phase, also known as offline testing. During this phase, the performance of the trainer model needs to be validated on the test set. Additionally, the model robustness should be assessed using noisy or wrong input data. Furthermore, it is the best practice to develop an explainable ML model to provide trust, meet regulatory requirements, and govern humans in ML-assist decisions. Finally, the model deployment decision should be made automatically based on success criteria or manually by domain and ML experts. Similar to the model phase, all outcomes of the evaluation phase need to be documented. And the next phase is deployment. The ML model deployment denotes a process of the ML model integration into the existing software system. After succeeding in the evaluation step in the ML development lifecycle, the ML model is graduated to be deployed in the pre-production environments. And the last final phase, monitoring and maintenance. Once the ML model has been put into production, it is essential to monitor its performance and maintain it. When an ML model performance on a real-world data, the main risk is the model staleness effect when the performance of the ML model drops as it starts operating on unseen data. Furthermore, model performance is affected by hardware performance and the existing software stack. Therefore, the best practice to prevent the model performance drop is to perform in the monitoring task. When the model performance continuously evaluated to decide whether the model needs to be retrained. This is known as the continued model evaluation pattern. The decision from the monitoring task leads to the second task, updating the ML model, additional to monitoring and retraining, reflecting on the business use case, and the ML task might be valuable for adjusting the ML process. Thank you so much for the opportunity. The next part will be continued by my friend Harshit.
Yeah, thank you, Ayappa. Thank you, everybody here giving me this golden opportunity. Yeah, next slide, please. Yeah, these are the technical specifications required for our project. So they are Anaconda Navigator, Spider for manual code writing, Anaconda Prompt for deployment stage, and the Google Colab for the auto ML accuracy check, and the GitHub for the web storage and the references. And we have used the Streamlit and Flags for the open source framework that is the platform as a network platform we are using here, the Streamlit and Flash. And the libraries we have used are Pandas, NumPy, Scikit, Learn, Matplotlib, Stats Model, Seaborn, SciPy. These are very familiar for the visualization, advanced visualization, scientific computation, data manipulations, as well as mathematical calculation. Next slide, please. Yeah, this is our project architecture. So in step one, we have done web scraping and surveyed details of price of competitors and loaded into the database. So loaded into the database, considering necessary attributes for the price prediction of new product of EdTech. So the second step we have done using all the different libraries required for the model building, we are manipulating the data set here. So in third step, we have done a cleansing the data. Here we have done removing outliers using vinsorization, removing duplicated values and computing the missing values using mean, median, and mode imputation techniques. So in step 4, we have done correlation and the regression analysis. So we considered all the attributes and finding the relation among themselves, whether they are strongly correlated or not strongly correlated. So in step 5, model building using multilinear regression. Here we got the parameters R square, P, and RMSE values and built different models. We finalized the best model based on R square value, that is greater than 0.85, and the P value which is less than 0.05, and the R value which is greater than 0.85. Test and train error should be nearly equal or less. So we cross-checked all these parameters using PyCaret. And in step 6, with the best result, we proceed for the development. The development is done using Flask, Streamlit, and Heroku platforms as well. So next slide, please. Yeah, this is the page, data collection and business understanding. So first we have understood the business problem, and after we have listed out the various factors that are affecting our prediction of price, and we have selected the main important features that are really affecting the business. Yeah, and after we have done web scraping through various websites, and we have inquired to the institutions and all we have done. So we have got the data and we have stored in the database. So, and after that, we have done handling. Yeah, we handle the noise data, and we have generated some random data too. And considering all the necessary details, and we have stored everything in the database. Next slide, please. Yeah, this is our data dictionary. Yeah, we have taken some important factors here: the location, level of course, a trainer qualification. So here we have taken the level of course as a level. I mean, beginner, intermediate, high, in that way. Yeah, trainer qualification also we have taken in the same notion: high, medium, low. And the level of maintenance, level of marketing also taken in the same phase: high, medium, low. And after we have taken duration of the coaching. I mean, we have taken the unit as hours here. So, and after we have taken maintenance cost as our feature, that is the cost required for electricity, infrastructure, salary of maintenance, and everything that includes in this maintenance cost. Next slide, please. And we have also taken the competitor's name here. So it's very simple. That's the name of the institute we have written. So the next, the mode of class. So they are offering online, offline, as well as blended. So we have included everything in that. So name of the course we have taken. So for every whatever the course they are providing, the tariff they are providing, we have mentioned that. And after the placement guarantee or assistance, placement guarantee, whether they are giving the placement or not, the guarantee. Yeah, we have mentioned like yes or no in that way. So we have included the marketing cost. This is a very important, and it includes cost of offline and online marketing, advertising, social media marketing, and promotion and content. So yeah, it's a very important. So we have included the marketing cost, and also we have included debentures too. Yeah, it includes annual amount of rent, tax, and loan. That's all. And the salary of the trainer we have taken. That this includes the salary of staff, expenses of guests, faculty, both offline and online. Yeah, the profit margin we have taken. The overall gain from the product we know very well that. Next slide, please. Yeah, and also the certificate issued or not, whether the certificate is issued or not after the completion of the course. That is the criteria here. Yeah, we have included these also in our data, and also the competitive price we have taken. These as actually we are the targeting the price actually according to the we are according to the competitive price. We are targeting the new price. These are very important. The overall price of the product in various institutes. Yeah, thank you so much. Thank you for this opportunity. So the next part will be explained by my friend Veena Dhari.
Thank you, Harshit. Next slide, please. Good evening, everyone. Myself, Veena Dhari. Now I'll explain about the data pre-processing part. Data pre-processing is also called as data cleansing, data organizing, or data wrangling. It is a data mining technique which is used to transform the raw data into a useful and efficient format. It involves 80% of the whole model building. The main steps involved in data pre-processing are finding the missing data, identifying the duplicates, outlier treatment, discretization, transformation, standardization, and normalization. We have also finding the first moment decision, second moment decision, third moment decision, and fourth moment decision. In first moment decision, which is also called as the measure of the central tendency, we find the mean, median, and mode. In the second moment decision, we find the variance, standard deviation, and range, which is called as the measure of dispersion. In third moment decision, we find the skewness, which is a measure of asymmetry in the data. And the fourth moment decision is the overall spread in the data, where we find the kurtosis. Next slide, please. In data pre-processing, we have used two methods. It is auto EDA technique and also the manual technique. In auto EDA technique, we use the SweetWiz library to find out the data pre-processing process. Here we can see that the mode of the class is a non-numeric data, and this we can see that the online people who have enrolled for the mode of class is 60%, whereas the offline and blended mode is less than 20%. Whereas when it comes to the name of the course, we have data science and other courses people enrolled are nearly more than 40%. Next slide, please. For the numerical data, we have done the first, second, third, and fourth moment decision, and the results are shown here. Next slide, please. This is the manual process of the EDA. First, we have identified the duplicates in our model and then removed them. Next, we have done we have found out the missing values, and the missing values are again taken out by numeric values are replaced with the mean imputation method, and the non-numeric values are replaced with the mode imputation method. Next slide, please. We have also found out the outliers. What are the outliers? Outliers are the extreme values that stand out greatly from overall pattern of the values in the data set. We have used a Winsorization technique and then removed all the outliers. Next slide, please. Next, we have found out the first, second, third, and fourth moment decisions, and the results are tabulated. Next slide, please. We have done the label encoding part, wherein the non-numerical data is converted into the numerical data. Next slide, please. We have finally done the normalization technique, wherein the data is converted into the range of 0 and 1. And with this, we come to the end of the data pre-processing process, and then we continue with the model building. Next slide, please. For this project, we have used the multiple linear regression model. What is multiple linear? It is simply called as a multiple regression, which is a static technique which uses several explanatory variables to predict the outcome of a response variable. Multiple linear regression examines how multiple independent variables are related to one dependent variable. It is an extension of ordinary least square regression because it involves more than one explanatory variable. Goal of multiple linear regression is to model the linear relationship between the independent variables and the responsible variable. Why we are using here multiple linear regression is we have several independent variables and one output variable, that is competitor's price. And the formula for the MLR technique is y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus so on plus beta p x3 plus epsilon, where y is the dependent variable, x is the independent variable, beta naught is the y-intercept, beta p is the slope coefficient of each explanatory variable, and epsilon is the error term. Now the model building part will be explained by my friend Diksha. Thank you for the opportunity. Thank you.
Thank you, Veena. Hello, everyone. Myself, Diksha. Here I will explain you how we have created regression model in Spider, its parameter, data visualization, and finally model accuracy comparison using AutoML technique in PyCaret using Google Colab. Here you can see how we have prepared the multilinear regression model in Spider. The model is created after the normalization of the dataset. For the regression, we have imported statsmodel.api. The first step is to build OLS model. OLS stands for ordinary least square. Initially, we have to build OLS model for competitive price as dependent variable with maintenance cost, marketing cost, debenture, salary of the trainer, mode of the class, and level of the course as independent variable. It is found that index number 61, 108, and 136 in the dataset showing high influence. So we have removed that from prediction. Similarly, we have created different OLS models for all the independent variables. The different OLS models give different VIF values. VIF stands for variable influencing factor, as VIF is equal to 1 upon 1 minus R square. That is, stronger the R square value, higher the VIF value. If VIF is greater than 10, it shows the collinearity in the variable. Manually, we have calculated different VIF values of the variable. So in the final model to predict the competitive price, we have considered maintenance cost, salary of the trainer, marketing cost, duration of coaching hours, mode of class, level of courses, and location. Next step is to predict the final model. Next slide, please. We have also done the residual plot. Residuals are nothing but the error between predicted value and observed value, and it should not be more. Next step, we have done train and test split. As we have come with different models and selecting the best model to fit, we have generalized it by using train and test split function. Dataset has been randomly split into 80-20 ratio as train and test dataset. We have implemented the logic in train dataset and predicting the test dataset. We are also calculating test RMSE and train RMSE values. Next slide, please. This is the summary of final model. In the first image, we can see that the correlation value of each independent variable with competitive price as dependent variable. We can see that the maintenance cost, marketing cost, debenture, salary of the trainer, and profit margin have high correlation values. In the right-hand side, we can see the RMSE, that is root mean square error for both test and train datasets. It comes out to be 0.0799 and 0.0590 test RMSE and train RMSE respectively. Ideally, RMSE values should be low and nearly equal for both test and train datasets. So we can proceed with this model for prediction. Below we can see the prediction result. It is in the best practice that R square, that is the goodness of fit, should be greater than 0.85, and we can see that it is 0.859. That is acceptable. The another parameter, that is probability F stat, that is the p value, which should be less than 0.05, and we can see that it is very less, and we can consider this also. All the parameter values in this regression model are considerable. Next slide, please. Apart from all the regression models, we have tried AutoML technique using PyCaret. Here we can see different models with their parameters and accuracy values. On the top of all the models, the linear regression model gives us best results with good R square value and least RMSE value. The linear regression technique is used for prediction of continuous values. On the comparison of both manual and auto machine learning technique tools, we have found that the AutoML faces problems such as data and model explanation. Furthermore, the current AutoML system optimization objectives are fixed. Often, realistic problems are a combination of multiple objectives like decision making and cost. With this kind of multi-objective situation is difficult to support current AutoML techniques with lack of explainability of our business objective. Hence, we have considered manual results over the AutoML results. Next slide, please. Data visualization. Here we can see on the left-hand side, the box plot of the variable duration of coaching hours and salary of the trainer, showing outlier values. We have treated the outlier using winsorization technique. On the right-hand side, we can see the relational and join plot graph, which shows the relation between the independent variables. Next slide, please. This is the pair plot of all the columns showing the relation between other variables. It is found that some variables are linearly related, some are moderately related. The pair plot help us to identify the pairwise relation between the variable in the dataset. Next slide, please. In the left-hand side, we can see the count plot. Count plot shows the count of the particular value. Here we can see one of the competitor price value comes 7 times. Some are repeating 5 times and 4 times as well. On the right-hand side, we can see the VIF plot. VIF stands for variable influencing factor. Here, row number 136, 108 and 61 influencing the prediction. So we have removed that row number from the dataset. And lastly, we can see that probability plot. Probability plot are plotted between theoretical value and practical value. The red line is the normal distribution line. Some of the data points are near the normal line and few data points are influenced by outlier, which we can see far away from the normal line. Thank you, everyone. The model deployment and scope of the project will be explained by my friend Rakesh.
Next slide. Thank you, Diksha. Hello, everyone. I am Rakesh. Now I will explain about the deployment. In deployment, initially, we have to build the model by our dataset and apply the regression model. Next, we need to save this file as a PKL file because it is easy to dump and load the data. Next slide, please. Next slide, please. Yeah. Then we have to write the HTML code for the front-end purpose. As per our requirements, we have wrote the code as per the front end. Next slide, please. Hello. Next slide, please. Later, we have to render this HTML and PKL file in app by using the class code. Then run it. In kernel, you will find a URL. Copy that URL and paste it in the browser. This is the localhost process. After that, you will see the output screen. With the help of GitHub, we connected to Heroku for the deployment. This way, we have successfully completed deployment. The key which is generated in the deployment process, we have copied that link and pasted in the browser. Next slide, please. This is the process we have done to see the results. Then after giving all the inputs, we see the prediction of the competitor price on the screen. Hence, that shows the successful completion of the deployment. Next slide, please. This is the output of our app. Marketing cost as 11,000, mark 5,000. Salary of the trainer is 7,000. Duration of the course is 180 hours. Debentures was 2,500. And mode of class was blended learning. Location was Telangana. Level of course is intermediate. Then we need to click the predict button. Then we need to click the predict button. This shows our required output. Next slide, please. Next slide, please. Challenges. Nowadays, there is a heavy competition in the EdTech industry. Many institutes provide these similar courses. To increase the customers, we need to provide free webinars, live sessions, and we should offer them discounts. To survive the competitor world, price optimization is one of the key aspects, whereas further growth of the business. We should have the updated system as per the time requirement. For the long term of the survival of the business, we should have the innovative ideas as per the trend. And these are some of challenges: slow monetization, high competition, resistance to change, privacy and data protection, global expansion cost. Slow monetization. Most profitable companies in EdTech monetize by choosing students as their customers. They market their educational products and services directly to students, completely circumventing the challenges of the working with university administration, but without selling user data. High competition. The number of EdTech startups has skyrocketed over the past couple of years. The increased competition for funding pushes startups to cut development costs, come up with innovative and acquisition strategies, or compromise on margins with competitors. Resistance to change. There is a lot of change in the way of learning today. Earlier, there were no online sessions, but during COVID times, there is lot of increase in online sessions. The way students learn has also changed with time. This resistance of change is a challenge. Next is the privacy and data protection. One student join in a program and share details with others is a concern. Privacy protection must be implemented for securing the data. And final one is global expansion cost. In recent survey indicates that global expansion is one of the biggest challenges among fast-growing edutech startups. Data protection, currency stability, and risky partnerships are other hurdles for edutech globalization. Future scope. Next slide, please. These are the some examples. Digital adoption among families and individual, updating according to technological needs and trend, dynamic pricing, awareness of edutech. Over the time, expenses and cost will change day by day. So the data which we prepared is good for present. Further data should be updated over the period of time. Next slide, please. With this, we came to the end of the presentation. Thank you so much to 360 DigiTMG team, our mentors, and our tutors for guiding and helping us in the project, providing the opportunities to explore our skills. And with this, we have wrapping up. If you have any queries, please ask us. Once again, thank you so much, everyone.